So this is the chapter 6 and 7 test review. We get into these first two problems. It says solve each system by graphing. There's two ways to do this. You can either graph it by hand or graph it on the calculator. If you want to graph it on the calculator, clear out whatever was in there, and you can go ahead and just type this one in because it's already solved for y. So we've got 5x plus 3. Oh, put that in the second slot. That's okay. I'll just put the other one in the first slot. Negative x minus 3. So I've got kind of my equations typed in backwards. The first one is in the second slot. The second one's in the first slot. Works out the same either way. We're just looking for an intersection point because that's what a solution is, okay? So I can see right here my intersection point. I can calculate that. And it should be -1, -2. So I know my intersection point is -1, -2 right there, okay? Pin a little bit smaller. -1, -2. There's my intersection point. But this says to graph them, and I want to graph them correctly. You can do that two different ways. You can either use the table to graph them, or you can graph them by hand. We can see here's our two intersections, 0, -3. This is one equation, all my y values, and this is my second equation, all my y values. You can graph them using the table, or you can graph them just by knowing what the equations mean. This means I have a y-intercept of +3 right there. And then this is a 5/1, so I've got to rise 5 and run 1. Or I can lower 1, 2, 3, 4, 5 and run 1 right there to my intercept. So there's my first line. It's an equation, so it's a solid line. My second one, I've got -3 as my intercept, and this is a -1 for a slope. So I can rise 1, run -1. Rise +1, run -1. Basically, it's going to go through all of those diagonals. And there was my intercept. There was my solution at -1, -2. Number 2, we want to do the same thing, but we can't yet. Okay, they're not in slope-intercept form. So we've got to take them and make them that way. Our first equation is 2 minus y equals -1/4 x. And we just need y by itself, so we subtract 2 from both sides. And then I need this to be a positive y, so I'm going to divide everything by -1. What that really does is it just flips all my signs. So one of my equations is y equals 1/4 x, so the negative, flip the sign, plus 2. There's one equation, okay? My second equation starts out as 4y minus x equals 8, and I need y by itself so I can graph it. I'm going to add x to each side. Right here, I go ahead and write the x in front because that's just how I'm used to seeing it. And then I divide by 4, divide by 4. And I've seen this mistake already a little bit today. When I divide x by 4, it's 1/4 x, because this would be a 1 in front of my x right here. 8 and 4 divide evenly, I get a +2. So there's my two equations. And I'm already looking to see, oh, well, that's odd. They sure do look pretty similar. If I go to graph this red equation, I start at +2. From here, you can also just put them in the calculator. But in the calculator, it's going to look a little tricky. I go up 1 over 4. 1, 2, 3. So there's my first equation. Then when I go to graph the black one, I see, oh, starting at the same spot. And what you know, we've got the same slope. So those are actually the same exact line. Therefore, I have an infinite number of solutions. Remember, there's another alternative method or another alternative answer. If I would have ended up with two parallel lines, not the same exact line, two parallel lines, those lines are never going to cross. Therefore, it would have been no solution. But this one was infinite. Number 3 and 4, we're still graphing. Number 3 is easiest to do just by graphing it by hand and knowing that this is a y-intercept and that this is our slope. Okay, just our definitions of equations. So for this first equation, we're going to start, or inequality, we're going to start down here at -3. We're going to go up 4, 1, 2, 3, 4 over 1. So there's our first inequality graph. Now, be careful because this is actually a dotted line, okay? And that's still something that trips a lot of people up. This is a dashed line, not dotted, a dashed line because it's not got the or equal to symbol. So I just go back and erase to make it dashed. It's hard to draw a straight line on the board with dashes. So there's one of my inequalities graphed, and now I need to shade. I tell you to take these one at a time, okay? This says less than. Well, anything that's less than means I'm going to shade below my line. I use these little arrows. It keeps things from getting too messy. Okay, so I'm going to use little dashes. Some people would just actually shade in the whole half. That's fine. My next inequality, I'll do it in red. It's starting at +3, and it's a -2 over 1. That means I'm going to rise -2. That means go down -2 and over 1 positive 1. So right to there, down 2 over 1, down 2 over 1, down 2 over 1. I can draw my line through all my points. And this one is an or equal to sign, so it actually is a solid line. I can leave it like that. Next, I've got a shade. This says less than, which means I'm shading everything below that red line. Notice I took these one at a time. I didn't think about, oh, what about both? What about this? What about that? Take them one at a time and then evaluate. Well, the only area that we've got that is double shaded is this bottom section. That's our double shaded region. It says write a solution and a non-solution. Well, a solution to this is actually going to be a point inside that double shaded region. I would be safe and pick something really far into that region, maybe all the way down here at the bottom or all the way down here, something that is easily in our double shaded region. Don't get too cute and try to pick something really close up here. You might have messed up with your graphic just a little bit. Maybe one of your lines is a little bit curved, kind of like mine. So I'd pick something way down here that's definitely a solution. Well, that point is at 1, -5. So your answer can vary. It does not have to be 1, -5. It has to be just anything in that double shaded region. For a non-solution, I need anything that's not in the double shaded region. That means you could pick a point way over here. You could pick a point way over here, but I usually tend to be as safe as possible, and I'll pick something up here that's really far away from my shaded region, and it's in fact in my not shaded at all region, just to be safe. That point I just chose was 0, 5. You can choose plenty of different options. Any point not in this double shaded region is a correct non-solution, okay? It's not a solution, it's a non-solution. Number 4 is very similar to what we did on number 2. We want to graph it still, but we can't yet because this is not solved for y. So our equation is, our inequality is 3x minus 2y is greater than -2, and we want y by itself. So I subtract 3x, subtract 3x. I have -2y is greater than, I go ahead and write the -3x in front. I'm just used to it being that way. So -3x minus 2. My final step, I've got to divide by -2 on both sides. Those cancel. I get a y, and then I'm careful and I pause because that sign, that symbol, inequality symbol, has to flip. It becomes a greater than symbol. -3 over -2, those don't go into each other, but the negative signs cancel out, and we get a 3/2 x. -2 divided by -2 is a +1. So now I'm ready to graph this. I start at 1, and my slope is up 3 over 2. Up 1, 2, 3 over 2. Down 1, 2, 3, left 2. Same thing. There's my line. And then I check. It was just a less than symbol, so I need a dashed line. Now I'm ready to shade. This says less than, so I'm shading everything that's less than or under my line. If you didn't flip your sign, you're going to shade the wrong side and you're going to get the wrong answer. You've got to be careful with